Good morning friends. Today we will study about lesson 1 chemistry part 2 video. We will study today about unit cell. I will show you my notes that I have prepared for you all students. So let's go there. So what is unit cell? First see, this is a crystal lattice. This is a crystal lattice. The crystal lattice part, you see, it is a cube, another cube attached here, another cube attached here, a warp down. In this way it can extend as much as you can. You can extend it as much as you can. But the highlighted part in green color which you see, it is a unit cell. If I highlight this part, then this will be a unit cell. If I highlight the middle part, then this will be a unit cell. Don't see this part, intersection part is nothing. So for your better understanding, let me make you clear that this highlighted part, not this part, not this part. If we this highlighted part is a unit cell. If I exclude this one and include this part, then this will be my unit cell. In this way you can take any one cube will be the unit cell. Unit means one. So any one cube will be the unit cell. So this is the unit cell here. I have shown you highlighted, and this whole structure, the cube will get extended, and that whole structure is known as the crystal or space lattice. Crystal lattice or space lattice. Then see here, what is crystal lattice? The three characteristics of crystal lattice. First one, each point in the lattice is known as the lattice site or lattice point. Each point represents one constituent particle. Do you remember what is constituent particle? This constituent particle, atoms, molecules, ions are the constituent particle. Each point in lattice is the lattice site or lattice point. That each lattice point represents one constituent particle. We join them by straight lines to show their geometry. Just see, here I have joined all these by straight lines. Somehow it have become curved and all those, but still then I hope you will be understanding what I am going to say. By straight lines I am getting its geometry. In the same way, these were all were the three characteristics of crystal lattice: lattice point, lattice site, then constituent particle. Then to show their geometry we join them by straight lines. Now we'll see what is unit cell. Unit cell is of two types. One is edge length or axial distance. The other one is interaxial angle. What is edge length or axial distance? Length or dimensions along the three edges A, B, C, which may or may not be mutually perpendicular. It may be or may not be mutually perpendicular, but that is not compulsory. But length or dimensions along the three edges A, B, C. Along the three edges A, B, C only. Let's see which may or then see interaxial angle. The same one, edge length and interaxial are almost equal types. But see what is interaxial angle. Interaxial angle is, this is it. This is a cube you see. You see the 3D structure, three-dimensional one. X-axis, obviously this iPad of mine is two-dimensional, but I have to make you understand how three-dimensional must be looking. So I hope you will manage with me. This is x-axis, this is y-axis, and this is the z-axis. In x-axis, see, here it is A. In y-axis, B. Z-axis, C. I have taken, suppose here the angle between y and z is alpha, x and y is gamma, and x and z is beta. How will you know the angle between y and z will be alpha, or between B and C? B and C will be alpha, beta among A and C, and gamma among A and B. How will you know that? Let me explain you. So see here, I have taken three edges, three angles, alpha, beta, gamma and A. Suppose मुझे लेना है यहाँ पे A और B के. A और B में कौन सा एंगल होगा ये हमें पता लगाना है. यहाँ पे हमने देख चुके हैं, यहाँ पे A और B में गामा एंगल है. हमें पता कैसे चलेगा? देखो A और B के ऊपर क्या क्या है, अल्फा और बीटा. जो उसके ऊपर नहीं होगा, ये एक ट्रिक है, जो उसके ऊपर नहीं होगा वो उसका एंगल होगा, गामा नहीं है, तो इसलिए ए और बी का एंगल गामा होगा। वैसे बी और सी में you see above it beta and gamma are present. Is alpha present? So B and C angle will be alpha. Let's see B and C the angle is alpha. Then the angle between A and C, see here, A and C, beta is not present as alpha is present above A and above C gamma is present. The one which is not present is beta. So the angle between A and C is beta. Let's see the angle between A and C. The angle between A and C is beta. So in this way, this is a trick. Here OA is A, OB is B and OC is C. I hope you will be getting what is O. O is the middle one, I have not written. So alpha between B and C, beta A and C, gamma A and B. Then types of unit cell. What are the types of unit cell? One is primitive, another one is non-primitive. In primitive unit cell, it consists of only 8 lattice points at 8 corners only. And the non-primitive one is divided into 3 parts. One is body centered and the face centered and the end centered. In body centered, only present at the corners. Only at the corners. At face centered, present at the corners plus present something at a face in between that. And end centered, 3 things present at the 3 means I want to say that 8 corners. The atoms will be present at 8 corners. In middle there will be 3. There will be 3, not 1. In face centered only at the face, but end centered also at the edges. 6 edges. So total 7 crystal systems possible. Basing on arrangement, 7 crystal systems possible. Now let me say you what are the 7 crystal system possible. Crystal habits, they are known as crystal habits. Cubic can be PUC, BC plus FC. PUC means primitive unit cell, BC means body centered, face centered. Age length A is equal to B is equal to C. Interaxial angles alpha is equal to beta is equal to gamma is 90 degree. Example AgCu, zinc plate, NaCl, KCl, diamond, Pb, Ag, CaF2. In this system, remember, this is the most regular system. This is the most regular system. This is the most regular because इसमें हर चीज़ सेम है. A, B, C, alpha, beta, gamma, everything is equal. So that's why. And possible variations, all 3. PUC, BC, FC. Then on tetragonal. Tetragonal, primitive and body centered. Face centered will not be possible. So face centered will not be possible means C is not equal. A is equal to B is not equal to C. But alpha, beta, gamma is 90 degree. So example CaSO4, white tin, TiO2, then stannum oxide, SnO2. Then orthorhombic. This also, here 4 are possible, all 4 arrangements, primitive, BC, FC, EC. But A is not equal to B is not equal to C and alpha, beta, gamma are equal. Rhombic, sulfur, Epsom salt and all these are examples. In monoclinic, PUC plus EC. A is not equal to B is not equal to C. Alpha and gamma are equal but beta is not equal. See, in monoclinic and triclinic, in triclinic, nothing is equal. So this is the most irregular system. Cubic, most regular. Triclinic, most. तीन तिगड़ा काम बिगाड़ा. You heard the proverb. तीन तिगड़ा काम बिगाड़ा. तीनों जन बिगड़े हुए हैं. पर मोनोक्लिनिक में एक ही बिगड़ा हुआ है. देखो, अल्फा, बीटा, गामा 3 बिगड़ा. पर यहाँ पे सिर्फ बीटा बिगड़ा. अल्फा, गामा सेम है. इसीलिए मोनोक्लिनिक 1 बिगाड़ा, ट्राइक्लिनिक 3 बिगाड़ा. Examples are here present. Hexagonal, only primitive. Rhombohedral or trigonal, primitive. Remember like this, last three are primitive. And primitive is common in all the crystal system. All the crystal habits, primitive is present. Cubic, tetrahedral. Then where is only body centered and face centered present? Body centered and face centered are present on cubic and orthorhombic. End centered present at orthorhombic, monoclinic. In this way you can remember last year only primitive. Examples are here present for you. For your betterment, I have showed the diagram here. Cubic, see the primitive structure of cube. Body centered one, face centered one. Tetragonal, primitive, body centered. Orthorhombic, primitive, body centered, face centered, end centered. 4 possible arrangements are possible. Monoclinic, एक बिगाड़ा. Triclinic, 3 बिगाड़ा. By seeing the structure of monoclinic, you will be getting the structure of triclinic also. Here in monoclinic, this is a primitive structure, end-centered structure. Then hexagonal, primitive, rhombohedral, primitive, and triclinic, primitive one. Okay. So these are the structures drawn for you. If you want, then you can see them all again. These are the unit cells of 14 bravais lattices. यहाँ पे देखो, number and contribution per unit cell. It's the contribution per unit cell. So see here, corners 8, contribution per unit cell is 1/8. Faces 6, half is the contribution. 12, then here is 1/4 because 3 surfaces are present and 12 into 1/4 is 3. Body center 1, body diagonal axis 4, 1, body diagonal plane 6, 1. If you are not getting how these numbers have come, then अपने घर में रहते हुए अपने दीवार को देखो, see the wall, look at it, and जहाँ पे ऐसे कुछ होता है ना स्ट्रक्चर, यहाँ से गया होता है, यहाँ से गया होता है, तो वहीं से यहाँ से जो स्टार्टिंग हुआ है सीलिंग का इस तरफ से लेकर सीलिंग का एंड तक इस तरफ से या कुछ इस तरह से, this is the body diagonal axis. This is the body diagonal axis, and this the middle part, the middle intersection is the body centered, and that plane is known as the body diagonal plane. So body only one is possible. Body diagonal axis 4, 1, 6, 1. See in BCC structure, body centered unit cell. Body centered unit cell. See, here is the half contribution. This is R. Here also R. But the middle one is full, so it is 2R. R plus 2R plus R whole square is equal to 3A square. 3A square, how it is 3A square? This is 1. This is 1. और नीचे वाला ये जो है दिख रहा है ऐसा 3 हो गए. 1, 2, 3. Okay. So it is 3A square. 4R is equal to root 3A. R is equal to root 3A by 4. In primitive unit cell, you can see here, this is R and this is half R. So 2R is equal to A, R is equal to A by 2. As the whole one is A, this whole one is A. So in pure, इसका diagram कुछ इस तरह होगा. This is the cube, this is the triangle. I hope you can see. This is the triangle. Here this is A, this is root 2A. So this one will be A square plus root 2A square का root over. तो रूट 3A आ गया. ये वाला स्ट्रक्चर बहुत कॉम्प्लिकेटेड होता है जब देखा जाए. देखो इस वाले सरफेस में हो सकता है ऐसे, ये वाले ऊपर के सरफेस में हो सकता है, नीचे के सरफेस में भी ऐसा हो सकता है. फिर कहाँ रह गया, ये वाला सरफेस में भी ऐसा हो सकता है, इस वाला सरफेस में भी ऐसा हो सकता है. तो ये स्ट्रक्चर बहुत कॉम्प्लिकेटेड होता है. जैसे कि मैंने ये क्यूब किया, आई डिड दिस एंड सी, ये वाला जो सरफेस है दिख रहा है तुम लोगों को, ये वाले सरफेस में हम इंटरडायगोनल एक्सेस कर सकते हैं, ये वाले में कर सकते हैं, इस वाले में कर सकते हैं, आगे जो दिख रहा है, नीचे में जो दिख रहा है, हर तरफ से ऐसे कर सकते हैं। और स्ट्रक्चर जब हम करेंगे तो ये कुछ इस तरह दिखेगा, ये कुछ इस तरह दिखेगा। तो यहाँ पे रुकते हैं आज के लिए, बहुत कम पढ़ा है, फिर भी आप और एक बार देख लीजिएगा, कुछ क्वेश्चन कर दीजिए और उसके बाद जो डाउट होगा कमेंट बॉक्स पे लिख लेना अगर हो तो। और नेक्स्ट वीडियो में देखेंगे क्लोज्ड पैक्ड स्ट्रक्चर्स के बारे में। क्लोज्ड पैक्ड स्ट्रक्चर इस 1D में होता है, 2D में होता है, 3D में भी होता है। हमारे बेसिकली चाहिए 3D वाला, इसलिए थोड़ा दिक्कत होता है पढ़ने के लिए। इस चैप्टर में से खास नहीं, बस 4 ही मार्क आते हैं, पर ये 4 मार्क बहुत इंपॉर्टेंट होते हैं क्योंकि लाने के लिए ईजी होता है। और 1D में बहुत सिंपल है, 2D भी बहुत सिंपल है, 1D 2D नॉर्मली यूजुअली बहुत ही सेम है, 3D में थोड़ा बहुत डिफरेंट है, तो उसे देख लेंगे, कोई बात नहीं। Thank you for watching the video.